Convert the Cartesian curve, x cubed plus y cubed equals 27, to a polar coordinate expression that specifically we're being asked for is r equals some function of theta. Okay, so we've got Cartesian, we've got the x's, we got the y's in here, and we want to get r's and thetas, and then specifically we're being asked to isolate for r in terms of theta. So that's sort of an extra little thing. So what do we know? Well, we know how to convert between polar and Cartesian. So for example, x here can be rewritten as r cos theta. So I can replace this x that I don't want the Cartesian coordinates, with the r's and the thetas. Same thing, y. Y is r sine theta. So we can plug them in, r cos theta to the 3, r sine theta to the 3 equals 27. And if all we wanted was a polar coordinate expression, boom, there it is, all done. But the question asked us, I want to isolate r. So now it's just a game of using our algebra skills. So what I might do, I might distribute the 3 here. So r cubed cos cubed theta. Same thing here, r cubed sine cubed theta, 27. And now we could factor out the r cubed. Yeah, cos cubed theta plus sine cubed theta. It's a shame these aren't squares, because then maybe they could add to 1 using the Pythagorean identity, but yeah, that's okay. Now we've got only one r, so we could divide both sides by this cos cubed sine cubed expression. And since we just want r by itself, how do we get rid of this cube? We cube root. Right. Now I'm going to go a little bit further. You can cube root 27 and get 3, and then we can stuff the cube root on the bottom. Yeah, there we go. R all by itself. I'll write the official answer back on the question page. 3 over the cube root of cos cubed theta plus sine cubed theta. And if you were to plot this in polar coordinates, you would get the exact same curve as you would in Cartesian if you plot this in the normal xy coordinates. I think, this is just off the top of my head, but I believe if you actually were to plot all these points, you get sort of a shape that kind of looks like this. Kind of almost like a line with a bump. Not exactly, but I think it's something to that effect. So it's kind of cool if you actually wanted to go through and graph these things. But yeah, these two are expressing the same set of points, which is what we call a curve.